Hi everyone, tonight I want to share with you a proposed explanation for the double slit experiment. So there's the wall with the slit. I have a wall. As the electrons pass through the first slit, what are they doing? They're accumulating in one line, right? A single line. And then when a second slit is open, they accumulate in an interference pattern. An electron emits an EMF, an electromagnetic field. An electromagnetic field will move faster than a particle. So even though the electron is passing extremely fast, the electromagnetic field that it produces will actually outrace it to the wall. It might be slight, but it will outrace it. So the electromagnetic field is actually passing through this slit, and just in front of the electron, it's moving forward and it's hitting the wall. Now, as long as there's only one slit, this isn't going to do anything, because keep in mind, we've got an EMF and we have a particle. So the EMF hits first, and the strongest charge is going to be where it hits the wall closest to the electron. So that's going to be directly in front of the slit. So that means there's going to be a charged surface corresponding to similar to that slit right here on the wall. So as long as that EMF is outracing the electron, it's producing that force and that EMF. And as we know, it's basically charging the wall with a charge. So that charge is actually now pulling the electron as well towards it on the other second wall. So now, what happens then when you introduce the second slit? Now, you have two electromagnetic fields. If you shoot an electron, even if you don't have to shoot two, you can shoot one electron. If you shoot one electron towards the slits, then the EMF, it's going to be like a wave, right? Because we compare the EMF to like a wave of water. So imagine a wave of water hitting these two slits. So one electron is producing one EMF. It's like one wave. And it'll work whether it's two or one. But it's important to know that it can happen with just one electron. So one electron produces the EMF. So just like a wave of water that's produced by one pebble, when it hits the two slits, the wave is going to go through both slits. And now those two waves are going to converge and form the interference pattern along the back wall. So my proposal to you is that even with a single electron, electromagnetic field from that single electron will outrace the electron to the wall. And if you want to argue against that and say, well, it's only slight, very slight, keep in mind many electrons are being fired in this process. So over time, each time an electron is fired, more electromagnetic fields go out, which means the interference pattern against the wall charges the wall stronger and stronger with time. Okay, so that gives the explanation as to why a particle, an electron, will form, in one case, will just form a line, and in a second case will form the interference pattern. Now, the other part is when you turn the light on, right? So the scientists, they were turning the light on because with a light, they're actually able to observe. There's a way they use light to observe electrons. And when they turned the light on to try to find out why this was taking place, then it changed the results. And so why would that be? So my theory that I'd like to present to you on that is also quite simple. When you turn on a light, what do? You create an electromagnetic field. Right? Everybody knows when you turn a light on, there's an electromagnetic field that travels through the wires. And so if you introduce another electromagnetic field to this situation where electromagnetic fields are driving where these particles are landing, then if you turn on another one, then it's going to affect the results. All right, so this is my simple explanation that I would like to give you guys. for what is considered one of the most troubling problems in all of physics, and that is the double slit experiment. Let me know what you think. Comments below. Alright guys, hope you have a nice night.